Good evening, everyone. A very good evening to all of you, bacho. We are live. We are back on exam dos. We are back with one additional session for electrostatics because there was a huge backlog of questions. So in this session, we'll complete the leftover questions and we will also discuss the assignments that are yet to be discussed. Chaliye. So yesterday I left all these questions as the homework. A point charge placed inside cavity 1 and another charge Q2 is placed inside cavity 2. Okay. A point charge Q is placed outside the conductor. If the potential of conductor is 10 volt, Q2 is placed at center of cavity 2. Then potential at point QR is. Okay. Now, this figure needs a little bit more clarity. Okay. Okay. So, this is the figure. This is a conductor of arbitrary shape. Now, there are two cavities. Okay. A point charge Q1 is placed inside cavity 1. The radius of cavity 1, R1 is not mentioned. Okay. Now, inside the cavity 2, R2 is 1.5, R2 dash is 1 meter. Okay. Now, R2 dash is 1 meter, where you have QR. This point is QR. At the center of this cavity, you have Q2. And there is a point charge Q outside the conductor. R2 dash is 1 meter. Okay, this is how the arrangement is. Potential of the conductor is 10 volt. Okay, and Q2 is 2 into 10 to the power minus 9 Coulomb. Clear हो गई यहाँ तक बात? Okay? Is this clear to everybody? Now what I want is, I want the potential at QR. Now listen to me very carefully. In case of conductor beta, charge inside the conductor is always 0. Correct? So by Gauss law, electric field is 0. Therefore, potential is constant. Potential inside is equal to potential of surface, which is basically 10 volt. Okay. Now, because of Q2 at the center of the cavity, there will be a minus Q2 charge induced here. Okay. Now, when you want the potential at QR, it will be same as the surface potential of conductor plus VQ2 plus V minus Q. Q2 की वजह से माइनस Q2 की वजह से और सरफेस वाला पोटेंशियल ऐड होगा. Now at the surface potential is 10 volt. Now Q2 is a point charge So you will take the potential at R2 dash. पॉइंट 4 से R2 dash पे लेंगे. What about minus Q2? Minus Q2 is over a cavity of radius 1.5. So when you take the potential inside, the potential will be same as the surface. Minus Q2 surface पे लाई कर रहा है ना, तो इसका पोटेंशियल जब अंदर लीजिएगा वो सरफेस वाला ही आएगा, यानी R2 लेंगे. ठीक है, स्फीयर या फिर कैविटी का रेडियस. ठीक है. Now what is Q2? 2 into 10 की पावर 9, 1 by 4 pi epsilon, 1 by R2 dash, 1 by R2. So 2 by 3, 1 by 3, 18, 6. So answer will be 16 volt. Clear हुआ ये? 16 volt. बेटा इस लेक्चर में क्वेश्चंस होंगे, बेटर है आपको आप पिछला लेक्चर कवर कर लो, क्योंकि क्वेश्चंस तो कैसे करोगे बिना पिछला लेक्चर देखे. The equipotential lines are shown below. Given that potential does not change with the z direction, electric field is minus gradient of V. Okay. Find the potential difference between the points 2, 1, 1 and 4, 2, 3. So I don't have to worry about the z coordinate. Potential does not change with the z direction. But what I need to worry about is the 2, 1 and 4, 2. Okay. 2, 1 and the 4, 2. Now these are the equipotential lines. So suppose this is line 1. If I write equation of line 1, पहली लाइन की अगर मैं इक्वेशन लिखता हूं, ठीक है, where potential is 14, so it will be pi minus 1, slope will be like this, x minus y equal to 1 plus 1 minus, this is y, 1 minus 2x. Okay. Similarly, line 2. These are all parallel lines, so the slope should remain the same. 2 minus 2. Why? Because it should become 0 at 1. तो यहाँ पे x 1 डालने पे 0 आना चाहिए, तो 2 minus 2x. इस तरह से लाइनें चल रही हैं. ठीक है. Now electric field is minus gradient of V, but I do not know the potential function. I just know the value of potential on different lines. So what I can say, 14 volt line is, then 12 volt, 2 minus 2x, 10 volt, 3 minus 2x, 8 volt. Like this we can continue. Okay. Now 2, 1 satisfies pi equal to 5 minus देखो जरा डाल के, x को 2 डालोगे तो y 1 आ जाएगा, 4,2, यहाँ पे पोटेंशियल अपने को मिल गया 6, 4,2, it will satisfy 10 minus 2x. So 4 volt minus 2x, 2 volt 7 minus 2x, 0 volt 8 minus 2x, and so on. Minus 4 will be 10 minus. So basically I found on which lines are these points lying. So Vp will be equal to 6 volt, Vq will be minus 4 volt. So delta V 10 volt आना चाहिए कायदे से, 10 minus 4 minus 2, 8 आ रहा है, 4 5 minus 6, 6 minus 7 minus, और ये वाला 5 minus 2, 4 minus 2 आ रहा है 5, 4 minus 2x माने 8. So this will come out as 12 volt. So first you have to figure out beta on which equipotential line will the point lie. So that way you can figure out the potential. Now two conducting plates of capacitor are at rho equal to 10 and rho equal to 20. Okay. The medium between the plates is 2.5 capacitance between the plates. So this is a cylindrical capacitor. Because it is given in terms of rho and height is given as 10 centimeter. Now you remember capacitance of cylindrical capacitor. This 2 pi came because of the phi. Now what is change in phi? 15 degree, which is pi by 12 radian. Length is 10 centimeter. Ln 20 by 10. .836 picofarad. Okay. So that will be the value. Simple. Recognize the capacitance. लाइन 2 थोड़ा बता दीजिए. देखो लाइन 2 जो है ना यहाँ पे 1 पे कट कर रही है, यानी कि इट शुड सेटिस्फाई 1,0. तो 1,0 माने x इक्वल टू 1 पे 0 आना चाहिए, स्लोप सेम रहना चाहिए. तो अब आपको स्लोप तो मिल ही गया -2, तो आप ऐसे लिख लो y माइनस 0 इज -2 x माइनस 1 आ जाएगा. ठीक है, एट x इक्वल टू 1 y इज 0, स्लोप इज -2. इस टाइप से Vp जो है बेटा 8 वोल्ट आएगा ना, 4 माइनस 2x को सेटिस्फाई कर रहा है. दिस पॉइंट इज सेटिस्फाइंग 4 माइनस 2x वेयर पोटेंशियल विल बी 8 वोल्ट. हाँ जी. A parallel plate capacitor whose plates are 10 centimeter square contains a medium. To maintain a steady current through the medium, 120 volt potential difference is applied. What is the resistance of the medium? Now beta, so this is a parallel plate capacitor. Now the plates are square. Okay. So now this area is 10 centimeters square. Okay. And this thickness is 0.2 centimeter. Now, how will the current flow through the dielectric, beta? Like this. So, when you take the resistance, it is rho L by area, where area is perpendicular to current direction. Okay. Area is perpendicular to current direction. So, you will take, what will be the area that you will take? That is 10 centimeter square, perpendicular to current. Okay. 10 into 10 to the power minus 4. And length you take in the direction of current. 2 into 10 to the power minus 3. So answer should be 5 kilo ohm. ठीक है, आंसर 5 किलो ओम आना चाहिए. Very good, रौनक. Answer will be 5 kilo ohm. मेरे भाई अब तुम नाम चेंज करके आ गए, जसवंत भाई गेट रैंकर बन के. अब भाई देखो यूट्यूब स्टूडेंट्स के ऐसा नहीं है कि मैं रोज ही डाउट बता पाऊंगा. Now here beta theta is 45. The number of image charge is 360 by theta minus 1. So it will be how much? 7. Correct? It will be 7. Next. The region between two concentric conducting spherical shell is filled with two different dielectrics. Okay. Total charge on the inner sphere is 4 microcoulomb. Find the electric field in the medium 1. तो मीडियम 1 में अपने को इलेक्ट्रिक फील्ड बतानी है. हमने दो अलग अलग डाइलेक्ट्रिक से इसको फिल करके रखा है. तो बेसिकली आउटसाइड स्फीयर इलेक्ट्रिक फील्ड इज सेम एज पॉइंट चार्ज. ये तो मैंने आपको बताया था ना, स्फीयर के बाहर निकालते हैं तो पॉइंट चार्ज जैसी ही इलेक्ट्रिक फील्ड आती है. तो 4 माइक्रोकूलम by 4 pi electric field tangent same आनी ET1 ET2. देखो मेरा पॉइंट यहां पे क्या है, एट द डाइलेक्ट्रिक इंटरफेस द इलेक्ट्रिक फील्ड इज पैरेलल. द इलेक्ट्रिक फील्ड इज पैरेलल टू द इंटरफेस. okay, when the electric field is parallel to the interface मेरे बच्चों, then you can say that electric field should be same in both the medium. देखिए what I mean to say, इलेक्ट्रिक फील्ड कैसे होगी, ऐसे होगी ना. ठीक है. So this is ET1 equal to ET2. This is the boundary condition. Electric field is tangential. We also understand this means it will be parallel capacitor. Now beta, how the dielectrics have been divided? The dielectrics have been divided इन थीटा, डाइलेक्ट्रिक्स को ना थीटा में डिवाइड किया गया है। So like this, from the first dielectric, theta will vary from up rather than this, ऐसे ले लो। Suppose you take this. To understand theta better, take this, theta 0. So this will be theta pi by 2. So one dielectric is from theta 0 to pi by 2 and the other one is between theta pi by 2 and pi. ये थीटा में डिवाइड हो रहे हैं ना आपके डाइलेक्ट्रिक, या फिर हम कह सकते हैं पाई में डिवाइड कैसे? अगर आप ऐसे लोगे, इफ यू टेक अ सर्कल हेयर, ठीक है, तो हाफ ऑफ द सर्कल विल लाई in the first dielectric, half will lie in the second dielectric. Actually they have been divided in phi. ठीक है, ये जो पिंक वाला सर्कल है phi में वेरी करता है, तो आधा सर्कल आपका एक में आ रहा है, आधा दूसरे में। एप्सिलन r1 pi varies from 0 to pi, एप्सिलन r2 pi varies from pi to 2 pi. Now capacitance of spherical is 4 pi, या फिर let us write like this. I told you the dissection of formula ना, right? ये मैंने आपको सिखाया था dissection. So instead of pi 2 pi, I will use pi. And because electric field is tangential, I have to take, because electric field is tangential, I have to take parallel capacitor. Like this. मैंने दोनों capacitances को add कर दिया. Now, I need to find the capacitance. 2 pi epsilon naught is 1 upon 18 into 10 to the power 9. Epsilon r1 plus epsilon r2 is 6. AB. AB is 2 into 4. 8 mm square. By 4 minus 2 is 2 mm. Okay. 24 by 18. 4 by 3 picofarad. 4 by 3 picofarad. Now voltage will be charge upon potential difference. Charge is how much? Charge will be 4 microcoulomb. Megavolt. But we wanted the electric field. How to find the electric? इस पूरे स्फीयर का चार्ज मालूम है, इतने कैपेसिटर्स भी मालूम है, इलेक्ट्रिक फील्ड कैसे निकलता है? इलेक्ट्रिक फील्ड कांस्टेंट, but here electric field will vary. इलेक्ट्रिक फील्ड यहाँ पे बदलना चाहिए डिस्टेंस के साथ, बिकॉज इट इज हियर, इट इज नॉट अ पैरेलल प्लेट कैपेसिटर. So I can find the voltage. How to find the electric field? Total charge on the inner sphere is given. मैं ऐसा सोच रहा हूँ कि दोनों इलेक्ट्रिक फील्ड बराबर होनी चाहिए, तो इसलिए चार्ज जो है अनइक्वली डिस्ट्रीब्यूट होगा. बेसिकली I can say Q1 by 4 pi epsilon 1 R square should be Q2 by 4 pi epsilon 2 R2 square R square. So Q1 by Q2 is epsilon 1 by epsilon 2. Okay. So that is 2 by 4. Q1 will be half Q. Okay, now Q1 plus Q2 is beta how much? Q1 plus Q2 is 4 microcoulomb. 1.5 Q2 is 4. 8 by 3. Q1 will be 4 by 3 microcoulomb. Now electric field in medium 1, Q1 by 4 pi epsilon naught epsilon R1 R square 4 by 3 microcoulomb 9 into 10 to the power 9 by epsilon R1 is 2 36 12 6000 by R square. अब ये इलेक्ट्रिक फील्ड दोनों मीडियम में सेम आएगी. ठीक है. And what about the voltage? Voltage we have already calculated 3 into 10 to the power 6. ठीक है. दोनों में इलेक्ट्रिक फील्ड सेम आएगी. सर 2 कैसे होगा समझ नहीं है. ये बताया तो मैंने लाइन का इक्वेशन लिखना बेटा. देखो ये वाला पॉइंट है 1,0. एक इक्वेशन लाइन की ये होती है अंकित भाई y माइनस वाई नॉट इज m x माइनस एक्स नॉट. ठीक है. तो पॉइंट है x नॉट y नॉट है 1 0, तो 0 1. स्लोप ये सारी लाइन पैरेलल है. स्लोप दिख रहा है यहाँ पे -2, तो इसका भी स्लोप लिया -2. आ गया इक्वेशन. तो -2x + 2 ही तो हो गया. ब्रैकेट में ले जाओ तो. चलो. टू कंडक्टिंग स्फेरिकल शेल. ओके. डी बाय एप्सिलन वाला भी लगाओगे तो डी तो पता होना चाहिए. डी बाय एप्सिलन तो लगा दोगे. टू कंडक्टिंग स्फेरिकल शेल द इंटीरियर इज अ परफेक्ट डाइलेक्ट्रिक. आई थिंक दिस शुड बी 6. लेट मी चेक. इट शुड बी 6 होना. 8 होगा. A portion of dielectric is removed. Epsilon r is 1 for 0 to pi by 2, pi by 2 to 2 pi. C1, C2. C1 is the capacitance with the complete dielectric as 8. C2 is the capacitance in second case. चलिए. So C1 will be 4 pi. It is a spherical shell. 4 pi epsilon naught into 8 into AB by B minus. Now for C2, okay, first the phi is varying from 0 to pi by 2. For phi limit, we are taking pi by 2. For theta, we are taking 2. Because theta, we take the integration of sine theta. Okay? We take integration of sine theta from 0 to pi. And when we are dividing the capacitance in terms of phi, the two capacitors are always taken as parallel. याद है ये बात मैंने बताई थी. रेडियली डिवाइड करते हैं तो सीरीज, and when you divide, when you divide in terms of theta or phi, it is parallel. C2a plus C2b, तो pi by 2 into 2 pi हो गया, pi ab. This is 3 pi ab, 24 pi ab, 25 pi ab by b minus a. C1 by C2 is 32 by 20, 70, 50, 1.28. ठीक है, the answer should be 1.28. Clear? V by L से तब निकालते हैं बख्शी जी इलेक्ट्रिक फील्ड, जब इलेक्ट्रिक फील्ड कांस्टेंट होती है, तब वोल्टेज बाय डिस्टेंस. Electrostatic potential is given magnitude of electric field. Now electric field is minus gradient of phi. So when you differentiate, it is like this. It is only in terms of x and y. So when you differentiate with respect to x, when you differentiate with respect to y, now at 1 comma 1, .236. Very easy. Electric field intensity is given. I want the potential difference. Okay. So Ex, which is equal to x, is minus del V by del x. So V will be Ey, which is y, minus del V by del y. So V will be Ez, which is z, is minus del V by del z. V will be minus z square by 2. Now, beta, now when you want Vy minus Vx, by 1 square plus 2 square plus 3 square minus 2 square. 9 and 1 10 minus, आंसर 5 आ गया. मैंने क्या किया? I converted the electric field into a potential function. Given the potential function, the direction of electric field. Minus del V by del xi, del V by del yj, del V by del z k. Minus 100x I, 100y j cap, 100z k cap. Now at 1 minus 1, 1, electric field will be minus 100I plus 100J minus 100K. So it will be, magnitude is 100 root 3, direction ये आ जाएगा, मैग्नीट्यूड हो जाएगा 100 रूट 3. अगर आप अंडर रूट ए स्क्वायर प्लस बी स्क्वायर प्लस सी स्क्वायर करोगे, डायरेक्शन माइनस आई प्लस जे प्लस माइनस के डिवाइडेड बाय मैग्नीट्यूड रूट 3. Two conductor occupying the surface rho equal to A and rho equal to B in cylindrical coordinates have V equal to 0 and V equal to V naught. The region between them is a perfect dielectric, and region from C to B is a dielectric of permittivity epsilon 2. Find the solution of potential in the two regions and the potential at the boundary, and hence find the electric field. अब देखिए, such kind of questions are the application of Laplace equation. There is no charge specified. So I can apply Laplace equation in the charge-free region. Now potential is a function of rho because the value of potential is given at different value of rho. So H2 H3 by H1, I will write like this. I will only take in the Laplacian the term concerned with rho. Now beta, because the derivative is 0, so you can say value inside the derivative is constant. So del V is m by rho, del V by del rho. So now V, if you integrate m ln rho plus. Now I do not know the value of m and n. But now if you see one more thing, we have divided the dielectric into two parts. So in the two parts beta, we have to define the separate potential function. Now I can take k1 log rho plus k2. Function will be same, but this k1, k2 will change from A up to C. Okay. K3 log rho plus K4 E up to. Now we need to find the four constants. Now potential at A is V0. A will lie in the first interval. First equation. Potential at B is 0. B will lie in the second interval. Two more equation I need. Potential at C minus should be same as C plus. यानी कि at C, the left hand limit should be equal to right hand limit. K1 log C plus K2 is K3 log C plus K4. Third equation. For fourth equation, na beta, I have to frame the electric field. Electric field is minus gradient of potential. So minus del V by del rho, A rho cap. Now, we know that electric field is normal to the interface. देखिए how? Interface is the boundary, rho बराबर C. So normal is A rho cap. So electric field is perpendicular to interface. So at perpendicular, what is the condition that we have? dn1 equal to dn2 minus epsilon 1 k1 by c minus epsilon 2 k3 by c. Because this becomes epsilon 1 en1 epsilon 2 en. Fourth equation. So from here beta, you need to find the four constants and then you will get all the answers. मैं आपको ये दिखाना चाहता था how to basically use the Laplace equation. Logic clear हुआ? How to use the Laplace equation beta? How to solve? Okay, clear हुआ? Next, a parallel plate capacitor has total charge Q and a breakdown voltage V. Now, a slab of dielectric constant 6 is inserted, maximum breakdown voltage and charge at this voltage. Now, if you see beta, the dielectric is divided along the area. The dielectrics are divided along area. What does this mean? This means parallel connection. In parallel connection, what is the quantity that remains same? Potential difference remains same. Therefore, breakdown voltage will remain same. Okay. तो breakdown voltage तो नहीं बदलने वाली. Now, what about the charge? So, initial capacitance will be epsilon naught A by D. Now, for the next case, the area is equally divided, because if you see L by 2, L by 2, so area is equally divided. So 3, because epsilon R is 6. C2B, where air is present. So C2 will be now I have told that the voltage will remain the same. Q2 will be C2V, Q1 will be C1V. So Q2 by Q1 will be C2 by C1, that is 3.5. So charge will become 3.5 Q, voltage will remain the same. Charge जो है 3.5 times हो गया because of capacitance, but voltage will be the same. Now capacitance of this arrangement, okay. So let me say there are 3 capacitances, CA, CB, CC. Now CA and CB are connected in series because they are divided along thickness, while CC is parallel. So for CA and CB, area is half of 20 into 20. स्क्वायर कंडक्टिंग प्लेट है ना बेटा, तो एरिया इज 400, तो उसका आधा आया 0.02. सीसी के लिए भी इतना ही होगा. नाउ सी एप्सिलॉन नॉट एप्सिलॉन R1 0.02 बाय थिकनेस इज 10 सेंटीमीटर. CB एप्सिलॉन नॉट एप्सिलॉन R2 0.02 by thickness 0.1. Epsilon R2 is, now this is in series. ये CB by CA plus CB. For CC beta, area is 0.02 but thickness here is 0.2. Now epsilon R3 is 4. So overall C is C1 plus CC, 0.4 plus 0.4 by 3. 1.6 epsilon naught by 3. 4.722 picofarad. बहुत बढ़िया रौनक भाई, बहुत बढ़िया. 4.722. A composite parallel plate capacitor is made of 2 different dielectric material with thickness T1, T2. They are separated by a conducting foil. The voltage of the conducting foil. So now beta, if we assume here the voltage is 0, so this is 100. So this is the voltage of foil. So voltage of foil will be same as the voltage across the capacitor 2. Now these two dielectrics are divided along the distance, so they are in series. T1 is epsilon naught epsilon R1 A by T1. T2 will be epsilon naught epsilon R2 A by T2. Now what is C2 by C1? Epsilon R2 by epsilon R1, T1 by T2. 4 by 3, 0.5 by 1. So 2 by 3. So what is V2? It is total voltage into C1 by C1 plus C2. 100. 1 plus C2 by C1. 60 volt. Very good beta. A parallel plate capacitor is partially filled with glass of dielectric constant 4. Dielectric strengths are given 30 and 300. Maximum voltage that can be applied without breakdown. Now first see beta how the electric field will be. It is normal. What is the boundary condition in the normal case? So electric field is normal to interface. So the boundary condition is dn1 equal to dn2. So that is 1 epsilon naught E1 should be equal to 4 epsilon naught E2. So E1 is 4 E2. Now beta, if I take electric field of air is 30, then E2 will be 7.5, which is less than the limit 300. But if I take electric field of glass 300, then E1 is 4 E2 1200, which is more than 30. So it will lead to breakdown. So this case we have to take where the electric field is 30 in first medium, 7.5 in second medium. 30 kV per centimeter, E2 7.5 kV per centimeter. Now मेरे बच्चों, voltage, because electric field is same, E into thickness we can do 30 into 10 mm 5 mm 0.5 सेंटीमीटर. ये पर सेंटीमीटर है ना, तो लेंथ सेंटीमीटर में कर लेना. 7.5 into 0.5 3.75 18.75 kV. 18.75 kV. Two conducting surfaces are present at x equal to 0 and x equal to 5. The space between them is filled with such that 0 to 1, 1 to 3 and rest is air filled. The capacitance per meter area. Now beta, again we are dividing along the thickness. So A, for the first one beta, thickness is 1 mm. For the second one, 1, 2, 3, thickness is 2 mm. For the third, air is the dielectric, thickness will be from 3 up to 5 mm. 2 mm. So 1 by C will be 1 by C1 plus 1 by C2 plus 1 by C3. What is epsilon R1? 2.5. What is epsilon R2? 4. What is epsilon? This is 2. 0.4, 0.5, 0.9, 2.9 by epsilon naught A. So C will be epsilon naught A by 2.9. But it is asking capacitance per unit area. Now this 2.9 is going in mm. .053 nanofarad per meter square. Okay, clear हो गया? Just give me a moment and then we will start the assignment discussion. फिर assignment start करते हैं. चलो भाई, हाँ जी, over the surface I need this surface integration. Now ds vector I will choose as y, because this will be in r cap, where the direction of the vector field is. So I will get 3r square sine square theta d theta. Now theta will go from 0 to pi, pi from 0 to 2 pi. And radius is mentioned as 5. So 3 into 5 square. Now both the functions are independent, the function in theta and phi. Both functions are independent, beta. 75. This is 1 minus cos 2 theta by 2. Now integration of cos 2 theta will be 0 because pi is the period. In one period integration is 0. 75 integration of 1 by 2 will be pi by 2 into 2 pi. So 75 pi square. क्या डाउट है अंकित भाई? क्वेश्चन नंबर 22 का डायग्राम बता दीजिए एक बार. 22 का डायग्राम बेटा ऐसा है कि आपने क्या किया, पहले आपने कैपेसिटर की प्लेट्स को दो हिस्सों में बांटा, एक लेफ्ट एक राइट. अब लेफ्ट वाले के अंदर भी दो अलग अलग डाइलेक्ट्रिक लगा दिए. तो यानी ये जो दो डाइलेक्ट्रिक हैं थिकनेस में डिवाइडेड, तो ये सीरीज, और इनके पूरे कॉम्बिनेशन के साथ ये पैरेलल आएगा क्योंकि ये एरिया में डिवाइडेड है. पैरेलल प्लेट में जब भी एरिया बांटोगे तो पैरेलल, थिकनेस बांटोगे तो सीरीज. बस ठीक है. R dot ds over the closed surface of the cube bounded by where r vector is the position vector. Now beta, here we can apply divergence theorem. Then divergence of r vector will be 3. So we will get 3 dV. That is 3 into volume. What is the volume of a cube? Length into width into height. So answer will be 3. Over the closed surface of a sphere of radius r. Again beta, apply divergence theorem. Apply divergence theorem. Then del dot r vector will be 3. So this will become, when you write like this, r dot ds del dot r dv. So that is 3 dv. Integral of dv is volume. So 3 into volume. 3 into 4 by 3 pi r cube. Radius is given as 2. 32 pi. Okay, 32 pi. H vector is given. I need to find H dot dl. Okay. So let's do one thing beta. Now from A to D, you can say y is 0, z is 0. You are moving along the x-axis, so dx ax cap. So what will be H dot dl beta? X minus y dx, but because y is 0, x dx. And x is varying from, this should also be 1, x is varying from 1 to 0, so it is minus half. And do not say, sir, we are moving inward, so I will take minus ax cap. No, that is taken care in the limits. Now then next, then you go from D to B. You are moving along z-axis, so dz az cap. Okay. and then x is 0, y is 0. So h dot dl is 5 y z dz. I will take the dot product with the z component. Now because y is 0, this is 0. Now I need to integrate from B to C. It is a straight line, B to C. So this point is 0, 0, 1 and this point is 0, 2. When you talk about BC, x minus 0 by 0 minus 0, y minus 0 by 2 minus 0 and z minus 1 by 0 minus, that is t. So y will be 2t and z will be 1 minus t. Now dl will be dy j cap plus dz k cap. Only y and z coordinates are changing. You can write like this: dy by dt j cap, dz by dt k cap, dt. 2j minus k dt. So h dot dl will be, okay, and x will remain 0 in BC. X square plus yz j into j 5yz 2 minus. Now x will be 0. So 2yz minus 5yz, and always remember t will go from 0 to 1. So minus 3 plus 2, it is minus. So now the total integration will be minus half plus 0 minus 1 to minus 1.5. डेल डॉट आर पोजीशन वेक्टर है, स्फेरिकल में कन्वर्ट, स्फेरिकल में आप करके देख लो बेटा डाइवर्जेंस, या फिर आप कार्टेशियन में करो, आपको 3 मिलेगा. यू कैन राइट इट एज xi plus yj plus zk. तो डाइवर्जेंस व्हेन यू कैलकुलेट del x by del x, del y by del y, del z by del z, all will be 1. So divergence will be 3. ठीक है, so divergence of position vector is always 3. Now d vector is given, a region is given. I need the surface integration. Now cylinder is a closed surface. So I will apply the divergence theorem. Go into 2 rho z square. Now 2 rho square is 4 rho. Second term derivative will be 0 because there is no term containing z. I will convert it to volume integral. Now beta, after converting this to volume integration, what can we do? I will write dv in cylindrical coordinate. Now I will separate the integration. Z will go from minus 1 to 1. Rho will go from 0 to 5. Pi will go from 0 to 2 pi. Okay. 4z square, it will be 4 by 3 z cube. D phi 2 pi. Rho square by 2 is 25 by 2. 100/6, 200π/6, ये 8 हो जाएगा, 8/3, 200/6, 100π/6, ये आ रहा है 50π/3, 209.43। तो एक बारी ऐसा नहीं बन रहा है, 8/3/6, π/, 100π/3, 200π/3, 209.43। The line integration along a path parameterized by this. Now, when parameterization is given, five xz x is t, z is t, x is t, 4yt, x square z, 5xz, तो square 1, 2t, 3x square, 6t cube, 5 over 2t, 4t, 5 over t square, 4ty, 4t cube, x square z is. Now, beta, x is t. So, when x is 0, t is 0. When x is 1, t is 1. So, t is going from 0 to 1. 5/3 plus 11/4. 4.4166. ये आ रहा है, बहुत बढ़िया। Vector field S is the surface of the unit cube. Again, beta, cube is a del by del y, del by del z. ठीक है, when I see a closed surface, I prefer to use the divergence theorem. The second term does not have any y, so derivative 0. So this is the volume, beta. Now, because it is a unit cube, so volume will be 1. Unit cube का मतलब जिसका side 1 unit है. This question is incomplete. Just a minute. check this. क्वेश्चन कंप्लीट। आपको ये निकालना है x dy minus y dx. Okay, x dy minus y dx. Now beta, here you can use the mathematics Green's theorem. So it is a 2D version of Stokes theorem. It is a 2D version of Stokes theorem. Okay, so in this case beta, m is minus y, n is x. So del n by del x is 1. Del m by del y is minus 1. So that means 2 times dx dy. A integration dx dy is the area. Now how to take the area beta? Area is rectangle. The width is 3. The height is 2. And the semicircle of radius 1. So 3 into 2 rectangle plus half pi 1 square. Pi by 2 6 plus pi by 2 12 plus pi. So answer will be A आ जाएगा. F is given, I need gradient of f dr over the contour. Gradient of f dot dr. देखो यार, if you compute f at final point minus f at initial. So what happens is, if a vector field is equal to gradient of scalar, अगर एक वेक्टर फील्ड एक स्केलार फील्ड का ग्रेडियंट है, then it will be conservative. So basically here f becomes the potential function. So to take the final point and the initial point, 2 का क्यूब 3 6 का स्क्वायर 4 minus 1 minus 2 into minus 3 का क्यूब 3 into minus 3 का स्क्वायर 4 into 2 16 plus 108 minus 4 minus minus 54 plus 27 plus 8. 124 minus 4 120 35. So it should be 139. एक बारी कंफर्म करो, यही आ रहा है बेटा? कर्ल तो 0 आएगा ही ना, मैंने f दिया है, मैंने तो ग्रेडियंट दिया ही नहीं है. मैं तो बोल रहा हूं ग्रेडियंट का इंटीग्रेशन करो, कर्ल ऑफ ग्रेडियंट विल बी 0. So this grad f is basically a vector field whose line integration I am asking. Now if I am obviously giving you f, that becomes the potential function of the vector field grad f. del cross f, where S represents the portion of the sphere for z greater than equal to 0. यानी upper half of sphere. Now del cross f. Now beta, there is no indication that it is a closed surface, so do not go after divergence theorem. Divergence लगाने मत लग जाना. अगर ये कंप्लीट स्फीयर दिया होता ना, तो आई वुड डायरेक्टली जंप टू द डाइवर्जेंस थ्योरम. आई कैप 1 माइनस del by del z 0 minus j cap del by del x of y del by del z plus k cap 1 minus I plus j plus k. Okay. I plus j plus k. Now what is ds vector? Gradient of s by mod of gradient. What is the gradient of s? 2xi, 2yj, 2zk by the magnitude. Now take 2 common. The denominator x square plus y square plus z square will be 1. ठीक है. Now curl of f dot ds, when you write na, you write as n cap ds. X plus y plus z. ठीक है. This is x plus y plus z ds, but ऐसे ही करना है. पड़ जाएगा. इसका ना एक ऑल्टरनेट रास्ता बताता हूं. Take the hemisphere. This is the upper half of the hemisphere. Okay. This is C. ठीक है. That is the rim of hemisphere. It is basically a closed curve. So sometimes we apply the inverse Stokes theorem, beta, which is like this. Now this is in the xy plane. So zax plus xay plus yaz. Now dl in the xy plane. F dot dl. ठीक है. Now beta, in xy plane z is 0. So f dot dl becomes x dy. Now when you want to integrate x dy over a closed curve C, do one thing. Write x as r cos theta. Y is r sin theta. So derivative will be r cos theta d theta. Now theta will go from 0 to 2 pi and radius will be 1. So cos square theta d theta 1 plus cos 2 theta by 2. So integration of 1 by 2 will be pi, cos 2 theta will be 0. तो ऐसे पाई आ गया. तो कई बार ना स्टोक्स थ्योरम में उल्टा भी हम लोग चले जाते हैं. हाँ, यूपीपीएससी पॉलिटेक्निक लेक्चरर का होगा बेटा, जल्दी अनाउंस करूंगा इसी वीक के अंदर. ठीक है, बहुत सारे अनाउंसमेंट है एजेई वाले बच्चों के लिए. इस वीक के अंदर सारे अनाउंसमेंट्स कंप्लीट कर दूंगा. ठीक है, चलो ये क्लियर हो गया. सो इट इज पाई. चलिए, नाउ बेटा आई विल कम टू द असाइनमेंट ऑफ लेक्चर 3. ये मुझे लग रहा है यहाँ पे लिखा है 60 वोल्ट पर मीटर. ओके, एंड amount of charge contained, the amount of charge contained will be. ठीक है, we need to know the amount of charge contained. Now by Gauss law I already know that the amount of charge is equal to the flux, and it is saying, it is seen that electric field is directed vertically down. At 300 meter it is this, at 200 150. What is the net charge? So beta, at this surface electric field is entering, at this surface it is leaving. So when it is entering, the flux will be negative. When it is leaving, flux will be positive. And what is the area? Area, 100 meter edge is the cube. Cube का edge है 100 meter. तो area will be 100 square. ठीक है? So what is the leaving flux? D is epsilon E. Entering pi net is leaving minus entering. So 90 epsilon naught into 10 to the power 4, 9 into 10 to the power 5 epsilon naught. इसमें ऐसे पूछा गया था, तो आंसर विल बी 9. ठीक है, आंसर विल बी 9. ये बात समझ में आई? 54 कहाँ आ रहा है? 9 आ रहा है ना, क्योंकि एरिया तो सेम ही है, इलेक्ट्रिक फील्ड अलग अलग है. A point charge is located on the disk of radius r meter at a distance 8 meter from the plane of the disk. If 1/4 of the flux from the charge passes through the disk, then r equal to k into 8. What is the value of k? So basically what it says is, this is a disk. Now beta, I have a point charge along the axis of the disk. ठीक है, at a distance 8 meter, we have a charge equal to 2 coulomb. Now, 1/4 of the electric flux from the charge passes through the disk. That means the flux will be q by 4. Flux हुआ q by 4. dl तो सिर्फ d थीटा होगा ना लास्ट क्वेश्चन में, e डॉट dl. कौन सा वाला वही बोल रहे हो बताओ? dl तो सिर्फ d थीटा होगा. कभी dl d थीटा हो सकता है, r d थीटा भी हो सकता है, d थीटा कैसे हो सकता है? d थीटा तो एंगल हुआ ना, लेंथ कैसे हो सकता है बख्शी जी? Now there is one way of doing this beta. Divide the disk into small rings. Take the radius of the ring as, let us say, x. So what will be the electric field? For flux density, I will say D. 8 square plus x square. ठीक है? But this is oriented at angle theta. For finding the flux beta, I need the perpendicular component. ये perpendicular component चाहिए होता है ना, तो D normal will be D cos theta. What will be cos theta beta? It will be base upon hypotenuse. In this triangle, the base will be 8. Q is 2 Coulomb. Okay. Now, beta, for the small flux, it is dn into small area. Now, the thickness of this ring, you take it as dx. Thickness इसका dx ले लो. So, what will be 16 by 4 pi is 4 upon pi. So, what will be the area? Circumference into thickness. ठीक है बेटा? क्लियर हुआ यहाँ तक? Now this x can vary up to the radius of the disk. X can vary from 0 up to r. So total flux will be 8 x dx now 64 plus x square is t square, x dx is t dt. Cube 1 by t cube is t to the power 1 by t square is minus 1 by t. So 1/4 of the flux means q by 4. The total flux is equal to charge. By 4. So half eight x dx r equal to k into at 8 meters. तो कहाँ गलती हो रही है यार? बेस तो हमारा 8 मीटर है, कॉस थीटा जब मैं लूँगा तो 8 अपॉन हाइपोटेनस आ जाएगा, आ गया 8 ऊपर चला गया, और नीचे Q/4 पाई हमने लिखा था, Q/4 पाई आर स्क्वायर, पॉइंट चार्ज है, Q/4 पाई आ गया। फ्लक्स इसका आता 860/4 पाई, तो 4/पाई हो गया, फिर 2 पाई x आ गया, तो 8x दी 8 60 3। वैल्यू ऑफ k शुड बी √3, ये k आ गया √3, ठीक है, क्लियर हो गया, k comes out to be √3, that is 1.732. A solid conducting sphere of 10 centimeter is enclosed by a thin metallic shell of 20 centimeter. Charge q is given to the inner sphere. देखिएगा, we have a small sphere, conducting sphere, and we have a outer sphere. The radius is 10 centimeter. This is 20 centimeter. Now you are connecting them. You want to know the heat lost. Okay. Now initially beta, when we give a charge of 20 microcoulomb to the inner sphere, डिजिटल और मेजरमेंट नहीं हुआ है, डिजिटल कर सकते हो, मेजरमेंट तो 2 या 3 नंबर का आएगा टोटल। तो इनिशियल एनर्जी विल बी Q² ये मैंने बताया था ना, सेल्फ एनर्जी ऑफ अ कंडक्टिंग स्फीयर, दिस इज द इनिशियल एनर्जी। नाउ व्हेन यू कनेक्ट देम, आफ्टर कनेक्शन, charge on the inner sphere is Q1, charge on outer will be Q2, ठीक है। now Q1 plus Q2 will be 20, but the thing is that V1 should be equal to V2. So what is the voltage on the inner sphere? Because of itself, now because of the outer sphere, the potential inside is same as the surface of the sphere. यहाँ पे जो चार्ज Q2 आएगा बेटा, Q2 की वजह से जब यहाँ पोटेंशियल निकालोगे तो सरफेस वाला आएगा। Then when you take outside on the outer sphere, due to charge inside, the potential outside same as a point charge, the distance will be 20 centimeter. Due to itself, this will be cancelled. Now what does it mean? Q1 by 10 is equal to Q2 by 20. So it means Q1 will be 0. Okay, that means Q2 will be 20. So the final energy will be, the entire charge goes into the outer sphere. So energy lost is initial minus final q square by 8 pi epsilon naught 1 by 0.1 minus 1 by 0.2. Q square will be 400 into 10 to the power minus 12, 9 into 10 to the power 9 by 2. 8 pi epsilon नॉट है ना, इसीलिए नीचे 2 रह गया. 1 by 0.1 10 minus 5 5. तो 200 1800 9000 9 जूल. लॉजिक समझे? सारा चार्ज बाहर चला जाता है when you connect a conducting sphere placed inside another conductor, है ना. When you connect them, the entire charge will be transferred to the outer body. सारा चार्ज बाहर वाली बॉडी पे ट्रांसफर हो जाएगा. समझ में आ रही है बात? The entire charge will go outside. Find electric field intensity at 4,0,0 due to a finite length uniform charge distribution. Now, how to find the electric field beta? It is a positive charge. So, take a small charge here. So, what is the distance? 4 minus x. So, what is dE? Rho L dx by 4 pi epsilon. Now, beta, try to integrate vary x from 0 to 2 because the electric field is in the same direction, that is away from the charge. करना जरा, इंटीग्रेट करिए 0 से लेकर के 2 तक भाई. इंटीग्रेट दिस. देखो, because electric field is in the same direction ना, it can be directly integrated. So I will do one thing. 10 to the power minus 8 4 0 to 2. What is the integration? 1 by x square minus minus will be. So at 2 it will be 1 by 2 minus 1 by 4. 90 by 4 22.5. कंफर्म करो एक बारी, 22.5 आ रहा है क्या? कंफर्म दिस वन. 22.5 आ रहा है क्या भाई? चलो. Next, which of the following statement are true is not true? Del dot D is rho V. First of all, beta, it is homogeneous because epsilon does not depend on coordinate. Epsilon is same in all direction. Isotropic. Del dot D rho V. E dot d is charged by 2 epsilon naught. So answer D is incorrect because in the denominator it should be 2 epsilon naught. Two semi-infinite conducting sheets are placed at right angles. The point charge of Q is placed at D. The net force on the charge is this. अब देखिएगा how to solve this question. मैंने आपको पहले इसका इमेज चार्ज दिखाया था भाई. I already showed you the image charge for this configuration, right? So there are 3 image charges that we have to take. ठीक है. So this is Q. This will be minus Q plus Q minus Q. Now between plus Q and minus Q, the force is always attractive. And between plus Q and plus Q, the force will be repulsive. Like this. So there are 3 forces, beta. Now I will name these forces as F1, F2, F3. Now, what is this distance? It is 2D. Okay. It is at D distance, right? What is this distance? This is again 2D. What about this distance? It is the diagonal of a square 2 root 2D. Okay. What about the angle which it makes? The angle that it makes is 45 degree. So now what is F1? Q square by 4 pi epsilon 2D square. It is to the left minus I cap. F2 Q square by 4 pi epsilon 2D square. It is downwards, so minus J cap. And F3 Q square by 4 pi epsilon 2 root 2D square. Now the direction is cos 45I plus sin 45J. It is to the right and the up. ठीक है, मैंने 3 parts में तोड़ लिया. Now, whenever we are adding the forces, we have to add them as vectors. So Q square by 16 pi epsilon D square minus I minus J. This will make it 32. So 1 by 2 root 2I. Why root 2? Because of cos 45. 1 by 2 root 2. ठीक है, तो K के ऑप्शन दिए नहीं, तो क्या दिया यहाँ पे K Q स्क्वायर by 4 pi epsilon D square (1 minus 2 I by 8 root 2 1 minus 2 root 2 J by 8 root. So this factor is K. Factor is K. समझ गए? मैंने LCM ले लिया 2 root 2. Hollow metallic sphere of radius r is kept at 1 volt. What is the flux? Now beta, potential is 1 which is Q by 4 pi epsilon naught R. So Q will be 4 pi epsilon naught R, which is equal to flux. Gauss law says the total charge is equal to flux. In an infinite plane, there exists a uniform surface charge density. What is the electric field strength? 2s by 2 epsilon 1 by 6000 pi by 2 epsilon. Now beta 1 by epsilon is, मैंने उस दिन आपको बताया था ना, what is 1 by epsilon? 36 pi into 10 की power 9. So 36,000 pi, so it is 3 AY. Why AY? Because the normal for an infinite sheet electric field is in the normal direction, which is AY cap. A metal sphere with radius 1 meter, surface charge density 10 is enclosed in a cube. Total outward displacement normal to the surface. So total flux equal to charge enclosed. Outward displacement का मतलब ये है, that is the total outward displacement. Basically it is the flux. Why beta? Because the D vector is known as the displacement vector. D vector को हम displacement vector के नाम से भी जानते हैं. Because it is a surface charge on the sphere, surface charge density into area. Surface charge है ना, तो surface charge density into area. So answer is A. Electric field strength is given. It is immersed in water. What is the surface charge density? For a perfect conductor, it is sigma by 2 epsilon. T20 epsilon naught. T20 by 36 pi 10 to the power minus 9. बट वो शीट पे होता है ना, सिर्फ कंडक्टर है, तो सिग्मा बाय एप्सिलन होगा. It is just a conductor. It is not mentioned as a infinite sheet. Answer will be, मैंने बताया था ना, it is normal. The normal component is sigma by epsilon, है ना. Electric field at boundary of conductor and dielectric, मैंने बताया था, it is always normal and the value is sigma by epsilon. Sigma is nothing but surface charge density. Uniform surface charge density 60 at x equal to 8. Now 1 by epsilon. Now A n cap. See, the plane is x equal to 8 and the point is at 6. मैंने बताया था ना, subtract the coordinate of the point and the plane. So this is 18, 60,000. फ्लक्स डेंसिटी it is asking D 2s by 2 तो 30 माइक्रो कूलाम पर मीटर स्क्वायर माइनस आई कैप क्या आएगा डी पूछा है ना ई नहीं पूछा 2 point charges are placed along a straight line where should the third charge be placed such that it is subjected to no force इसका यार none of these आएगा दोनों चार्जेस देखो पॉजिटिव नेगेटिव है ना तो सपोज q1 q they are at 10 meter now if you place 5 meter from q2 to the right अगर आप यहाँ पे 5 मीटर रखते हो ये ऑप्शन so the pull of q2 will be much higher because magnitude of charge is same but distance is less distance कम होने से इसका फोर्स डोमिनेट करेगा the point is here yes the forces will be equal and opposite but q1 will push the charge away q2 will pull it towards it so the force will be added एक पॉजिटिव एक नेगेटिव पॉजिटिव वाला दूर ढकेलेगा नेगेटिव वाला पास खींचेगा वो भी नहीं बना 15 मीटर टू द q1 फ्रॉम द राइट इट इज सेम ये दोनों तो सेम ही है 15 मीटर फ्रॉम q2 अगेन force of q2 dominates तो नेट फोर्स इज नॉट जीरो ठीक है नेट फोर्स जीरो आ ही नहीं सकता q2 का फोर्स डोमिनेट करेगा भाई इसका नन ऑफ दीज if they were both positive charges beta then I can say that force will be zero where at the midpoint अगर दोनों पॉजिटिव होते ना तो बीच में न्यूट्रल पॉइंट बनता फोर्स जीरो potential produced by a uniform line charge is given E is then the magnitude of del cross E is 0 because it is del cross del F है ना electric field is the gradient of potential तो कर्ल ऑफ E will be 0 electric field is conservative सर आरपीएससी मेंस के लिए ईएमएफटी कहाँ से प्रिपेयर करें इस क्रैश कोर्स से कर सकते हो सफिशिएंट रहेगा ये ठीक है दिव्यांश क्लियर हुआ तो जस्ट अ मोमेंट देन आई विल स्टार्ट विथ लेक्चर 4 असाइनमेंट विच आई गेव यस्टरडे देखते हैं इसके भी कुछ क्वेश्चन बना लेते हैं कुछ बच भी गए तो कोई बात नहीं कुछ सब्जेक्ट इलेक्ट्रॉनिक्स के हैं यार देखो कॉम्प्रिहेंसिव से करोगे तो मेंस में फायदा होगा दिव्यांश भाई ठीक है चलिए आइए For a specific charge distribution, the potential as a function of x is given. Then what is E dot ds? Now beta E dot ds is charge enclosed by epsilon naught. Now what is charge enclosed? Charge enclosed is the volume integration of the volume charge density. Okay, the volume integration of volume charge density. Now मेरे बच्चों, first thing you must understand, by Laplace equation, del square V is minus rho V by epsilon naught. Okay. So now beta, because potential is a function of x, so you can write d square V by dx square. That is the Laplacian in Cartesian. Now if you see beta, potential is either linear or constant. Potential has two things, either it is linear or constant. In both the situation beta, the double derivative will be 0. Okay, therefore rho v is 0. Therefore charge enclosed is 0. And therefore the answer will be very good रौनक भाई, तो आंसर 0 आएगा. लॉजिक समझे? अगर सर मान लीजिए पैराबोलिक होता तो what we will do? Using this equation by taking double derivative of this graph, I will find rho v. Then I will find the charge enclosed in this volume. After finding charge enclosed, I will write E dot d. Figure shows three concentric thin spherical shell ABC of radii R, 2R, 3R. Shell B is earthed. A and C are given charges Q and 2Q. If charge appearing on 1, 2, 3, 4 are Q1, Q2, Q3, Q4, we have to match it. चलिए आइए देखते हैं. So 1 and 2 are the inner and outer surfaces of B. 3 and 4 are the inner and outer surfaces of C. So beta, the inner sphere is given a charge Q. That does not change. इसको आपने Q दे दिया, ये तो यही रहेगा. Now what all we need to consider beta? What all we need to consider? The potential of the earthed sphere should be 0. And the electric field inside the conductor should be 0. Okay. So now, how to make sure that electric field inside the conductor, this electric field inside B 0. Okay. Now, electric field inside B is 0 if charge enclosed is 0. Therefore, Q1 will be minus Q. Q1 minus Q हो गया. Now, it's not necessary beta that total charge of B will be 0 because B is connected to Earth and Earth is capable of supplying infinite amount of charge. B आपका अर्थ से जुड़ा है और अर्थ कितना भी चार्ज दे सकती है. Okay. Now Q3 plus Q4, because that sphere is not connected anywhere, it is equal to the total charge that was given to C, that is 2Q. Okay. Now, electric field inside C is also 0. So charge enclosed should be 0 inside C. So Q3 plus Q2 plus Q1 plus Q is 0. Now Q1 is minus Q. So you can say Q3 plus Q2 is 0. First, second. Q3 plus Q2 0 है. Now the last thing is that potential of B is 0. What is the potential of B? Okay. Now because of Q, the inner sphere, the radius of B is how much? R, 2R, 3R. 2R. Because of Q1, at radius 2R, it is 4 pi epsilon 2R. Q1 की वजह से. Then because of Q2, 4 pi epsilon 2R. But now for Q3, it lies inside. So you take the outer radius 3R. For Q4 also it lies inside. So you take the outer radius 3. जब स्फीयर के अंदर लेते हैं तो स्फीयर का रेडियस लिया जाता है. Now beta, these two will be cancelled because Q1 is minus Q. Okay. Now Q3 plus Q4 I know. Q3 plus Q4 is 2Q. Q2 by 2R plus 2Q by 3R. So Q2 will be minus 4Q by. So from second, Q3 will become 4Q by 3. And from first, Q4 will be 2Q by. ये बन गया. So Q1 is minus Q, minus 4Q by 3, 4Q by 3, 2Q by 3. So Q1 is minus Q, Q2 is minus 4Q by 3, Q3 4Q by 3, Q4. तो DCBA, DCBA. बहुत बढ़िया रौनक भाई. समझ में आया सभी लोगों को क्या लॉजिक हमने लगाया? क्लियर हुआ ये चीज सभी लोगों को? बताइए. बहुत ही प्यारा, बहुत ही बेहतरीन क्वेश्चन है बेटा. क्लियर हुआ? Let's see the next one, beta. A dielectric in the form of a sphere is introduced into a homogeneous field. A, B, C are points. Now, if we are introducing a dielectric, there will be a polarization, beta. है ना? Dielectric gets polarized. So electric field at A, due to negative charge, it will be like this. At C, due to positive charge, like this. At B, from positive to negative, it will be like this. So at A and C, electric field will support the external, it will increase. At B, it is opposite, it will decrease. C option. A और C पे बढ़ जाएगा due to induced field, but B पे कम हो जाएगा. 3 concentric spherical conductor are as shown. रौनक भाई सॉल्व किए हो क्या ऐसे देख के बता रहे हो? The dielectric between the inner two sphere has a permittivity 2 epsilon naught. Capacitance will between A and B. So beta, this is the case of series when multiple dielectrics are placed. Acha, we need to find between A and B. द इनर सरफेस इज अर्थ, उनके बीच का हमें दे रखा है, ए और बी के बीच में अपने को बताना है। अगर मैं अंदर वाले को चार्ज दे दूं, अगर अंदर वाले को क्यू चार्ज दे दें तो उससे इलेक्ट्रिक फील्ड निकाल सकते हैं। एंड आफ्टर फाइंडिंग द इलेक्ट्रिक फील्ड वी कैन फाइंड द पोटेंशियल डिफरेंस। बट द क्वेश्चन इज व्हाट विल बी द चार्ज इंड्यूस्ड इवन इफ वी गिव इट अ चार्ज, because it is insulator na, I cannot comment on the charge induced. Now beta, what we can do, the inner sphere is grounded, so it is earth. Okay, so let's do one thing. The capacitance of the outer spherical shell 4 pi epsilon naught 5 mm, capacitance of the inner spherical shell 4 pi epsilon naught 3 mm. Okay, but what about CAB? 4 pi epsilon naught. Okay, and for A beta, between A and earth actually there is a medium of 2 epsilon naught. जो अंदर वाला स्फीयर है वो अर्थ की तरह काम कर रहा है ना, तो आई एम टेकिंग द कैपेसिटेंस between the with respect to the earth, that is same as the isolated sphere. देखिए potential of C is 0, this is C, potential of C is 0, same as potential at infinity. Therefore between A and C, capacitance same as isolated sphere. Isolated sphere वाला ही capacitance आएगा. Between B and C, okay, now it will be 5 into 3 by 5 minus. So actually what is happening, see this, between A and B I have one grounding. Like this. So A and B will be in series. (20 and 24). (8 into 320). By 7. 40.909 pi epsilon naught into 10 to the power minus. Point 1285 एप्सिलॉन नॉट, ठीक है, ये आएगा 0.1285 एप्सिलॉन नॉट फैरेड। ये बात समझ गए? बट सीए में आइसोलेटेड स्फीयर की जरूरत नहीं पड़ती, ये तो निकाल सकते। हाँ तो आपको दिख ही रहा है डायरेक्टली, हाँ तो निकाल सकते हैं ना 3 और 1 से। But B and C cannot be directly connected. So C potential is 0. So I am saying between B and infinity, the capacitance will be same as CB. So it is 3 by 2. So 3 by 2, it is 12. So 20 into 12 by 32. 7.5 pi f. 37 point. Due to parallel 0.1178. मेरी बात समझना बेटा, देखो ए और सी का डायरेक्ट कैपेसिटेंस मुझे मिल जा रहा है, बट क्या मैं बी और सी का निकाल सकता हूं डायरेक्टली? बट सी का पोटेंशियल जीरो है, जो कि इंफिनिटी पे भी होता है, तो बी और इंफिनिटी के बीच का कैपेसिटेंस मुझे पता है। तो बेसिकली बी से ग्राउंड और ए से ग्राउंड मिल गया, और ए और बी के बीच का भी मिल गया। तो अब इसका मैंने सर्किट ड्रॉ करके सॉल्व कर दिया। अंडरस्टूड? चलिए, now there are three capacitors. The breakdown strength of capacitor A 40 kV, B 30 kV, C 30 kV. Capacitor A 20, B 10, C 40. Okay. Now these are connected. Find the maximum value of V such that no capacitor breaks down. देखो बेटा, for such questions, always remember. For such question, always remember. That series माने charge is same and parallel माने voltage is same. So to save the capacitor in parallel, choose the minimum of the two voltages. In series, choose the minimum of two charges. Now A is 40, A is 20, breakdown is 40. 40 kV. So CV. Okay. Next is 50 kV, 10 microfarad. 500 millicoulomb. Next is 30 kV, 40 microfarad. Okay. Now see beta, 20 and 40 are in series. Which charge should I take? I should take the smaller value, 800 millicoulomb. Okay, 800 millicoulomb. So the capacitance will be 40 by 3 microfarad. So what is the voltage? Q by C, 60 volt. Now 40 and 10, which charge should I take? I should take the smaller. Now charge will be, sorry, voltage will be 500 by 8. Now which should I choose beta? I will take voltage equal to 60. Okay. And C equivalent will be 40 by 3 plus 8, 64 by 3 microfarad. Okay. So the charge will be C equivalent into V, 1280 microcoulomb. Okay. Now for 10 microfarad, which is in series, (800 milli, 500 milli). So 800 milli by 40 by 3, 20, 60 kV आएगा. Okay, now these are in series. Which charge should I choose? I will choose 500 millicoulomb. And what is the capacitance? 40 by 3 plus 8 will be by 3. वोल्टेज, समझ गए। हर स्टेज पे सीरीज है तो मिनिमम चार्ज लेना और पैरेलल है तो मिनिमम वोल्टेज। 500 बाय 320 इंटू 47, 73.4375 kV। ठीक है, मैं एक बार चेक भी कर लेता हूँ, इज दिस द आंसर? हाँ, 73.47। क्लियर हुआ? क्लियर हुआ भाई, कैसे किया है मैंने? नेक्स्ट, a dielectric slab of 40 meter square, thickness 10 mm is inserted between the plates of area 80 meter square with a constant speed 20. Distance between the plates is 10 mm. Capacitor is connected to a battery of EMFE. The energy supplied by the source in 0.3 second. Now beta, when we are inserting the plate or when we are inserting the dielectric between the plate of capacitor, then what does that mean? It means that the capacitance is increasing. Capacitance बढ़ रहा है ना? So now initially the entire capacitance will belong to, ठीक है, it will belong to the air. The entire dielectric will be air. But finally it will belong to both air and the dielectric. Now we are inserting at a speed of 20 meter per second. Okay. So in 0.3 second, how much will it travel? It will travel 6 meter. ठीक है, कितना ट्रैवल कर जाएगा बेटा? 6 मीटर ट्रैवल कर जाएगा। The width of the plate is 8 meter. The area is 80 meter square. It means the depth will be how much? The depth will be 10. Now how to find the energy supplied by the source? Initially entire space is air. ठीक है, initially entire space air है। Now in 0.3 second, dielectric moves by 6 meter. Okay, 2 meter will be air. Now based on the area, this should be 10 meter. Area will be 60. ठीक है, the second area will be 20. Now epsilon r is 2, so 120 plus 20. Now beta, initial charge is Ci into V, final charge is Cf into V. Now battery is 20. So it is 60 epsilon naught V square by D. बैटरी से जो एनर्जी आती है ना, वो हमेशा चार्ज इनटू पोटेंशियल करके आती है। The distance between the plates is 10 centimeter, 0.0. Ten to the power minus 21.25 microjoule. ठीक है, तो ये आ गया. Draw the waveform of current with respect to time. ठीक है, एक सेकेंड. लेकिन ये डाइलेक्ट्रिक की लेंथ जो है 4 मीटर है ना. एक गलती हम लोग कर दिए. Entire dielectric enters the plates at t equal to 4/20.2 seconds. Then till it exits capacitance will remain the same. तो एक्चुअली ना 0.2 सेकेंड पे ही ये पूरा आ जाएगा. यहाँ पे हम ये गलती कर दिए. दिस शुड बी डिवाइडेड इनटू 4 मीटर. This should be 40. So this should be 120. 20 minus 80 is 40. 40. क्योंकि डाइलेक्ट्रिक की थिक लेंथ ही बेटा आपकी इतनी है ना. कितनी? 4 मीटर है. तो 66 मीटर अंदर तो जा ही नहीं सकता. Okay. Now, for the above question, if you want to draw the waveform of current with respect to time for t less than 0.2 second, tab length inside is 20t. So area of dielectric the thickness of the air will be total minus the length of dielectric inside. ठीक है. So C is C1 plus C2. So now it will be 400 by 0.01. 400 by 0.01. 4 into 10 की power 4. So this is 1000. 8000 minus 20,000 T. Okay. Now charge is CV. 20C. Current is dq by dt. Okay. Now beta, when will it start exiting? When does dielectric starts to exit? When it travels the entire length. Distance traveled is 8 equal to 20t 0.4 second. So from 0.2 second till 0.4 second, entire slab inside, so capacitance is constant and current V into dC by dt, because capacitance is changing with time, will be 0. Now for t greater than 0.4, now beta, dielectric completely leaves when it travels 12 meter. कैसे? 4 मीटर अपनी लंबाई, 8 मीटर प्लेट की, तो टाइम विल बी 12 by 20.6. So for t greater than 0.6, again capacitance is constant, current will be 0. But between 0.4 and 0.6, some part of the dielectric will be outside, some part will be inside. कुछ पार्ट डाइलेक्ट्रिक का बाहर होगा, कुछ अंदर होगा. This 20t. So this length will be 20t minus 8. So now area of dielectric, कितना एरिया बना डाइलेक्ट्रिक का? डेप्थ है आपकी 10, and what will be this? 8 minus 20t minus 8, 16 minus 20t. ठीक है? Here 160 minus 200t by 0.01. 400t minus 160. 400t minus 160 plus 160 minus 200t. This is the current. So beta, now I have obtained the equation of the current. I can plot the graph. Okay. So initially it is positive. Negative क्यों? T. यहाँ पे हमने बोला 20t अंदर आ गया है. थिकनेस टाइम के साथ गिरनी चाहिए. 20t minus 8 तो ये डिस्टेंस हुआ, हमने डिस्टेंस गलत लिया. 8 minus 20t minus, so how much? 16 minus 20t. The total length is 4. 12 minus. How much will this be? 8 minus 12 minus 20t. Twelve minus 20t into 10. Okay. Now 240 minus 400. 200 minus 2. Okay. हमने ना लेंथ गलत कैलकुलेट कर ली थी. तो 0 to 0.2 सेकेंड बेटा. 0 to 0.2 सेकेंड. It should be 4 into 10 की power 5. 0.2 to 0.4 0. Then again 0.4 into 10 की power 5 epsilon naught with a negative sign. 0.2, 0.4, 0.6. This is 4 into 10 to the power 5 epsilon naught. Okay, क्लियर हुआ कैसे करंट बनेगा? तो इसके आगे बेटा हम लोग ना कल कंटिन्यू करेंगे. टुमारो वी विल कंटिन्यू फ्रॉम हेयर. टुमारो आई विल डिस्कस दीज लेफ्ट ओवर क्वेश्चंस आल्सो. और आरआरबी जेई का स्ट्रैटेजी बेटा मैं ले चुका हूं. एक बारी वीडियो सेक्शन में चेक कर लो या लाइव सेक्शन में एक बारी सर्च कर लो अंकित गोयल आरआरबी स्ट्रैटेजी. ठीक है, ये बात क्लियर है. चलिए, तो फिर मैं आप लोगों से मिलता हूं बेटा, कल मिलता हूं. टुमारो लेक्चर विल स्टार्ट एट 4 PM. और कल हम लोग जो है मैग्नेटिज्म भी कवर करेंगे और ये बचा हुआ असाइनमेंट भी. ओके, चलिए, तो थैंक यू एवरीवन. आई विल सी यू ऑल टुमारो 4 PM. रिमेंबर द चेंज इन टाइमिंग. और कल से PYQ सीरीज भी स्टार्ट कर रहे हैं, तो वी विल डिस्कस द PYQs ऑफ ट्रांसफॉर्मर. थैंक यू.